Hello. Thank you. Okay. Digest this for a moment while I get ready. I will not take the 15 minutes, don't worry. You know what iRobot is, yes? Yeah. You see what this woman is doing, yes? There we go. Scattered laughs. Okay, so automation is not coming. It's here. And the reason that the cities look like this is not because Americans have some sort of burning desire to eat burgers and pizza all day, but because these kind of systems are very easy to expand and very easy to multiply. And what we believe in is we don't believe in food robotics, in automating fast food. Most of the food sold in the United States is burgers and pizzas and French fries. And as I said, it's not because people love it, it's because it's available. And I'm the head of culinary engineering at REMY Robotics. Here's a cool video of us doing culinary engineering. And what we do is we believe that the future of food and food technology should not be focused around fast food, but should be focused on disrupting the entire system. There's absolutely no point in making a more efficient McDonald's. Well, bueno, you automate 1% of McDonald's revenue, you've got billions of dollars. But the trend towards automation is very clear. It's happening. It's been growing for years. You can see agricultural output versus people employed in agriculture. And the way that companies normally approach this is we work with the automation of physical labor and we work with the automation of mental labor, right? And the thing is, what all robot companies end up hitting, and this is, I guess, what Zach will talk about later, the thing that they always end up hitting is that all of these actions that she is performing are incredibly difficult actions for a human to perform, let alone a robot. Like she's flipping, she's stir-frying, she's frying, she's touching heat. You could make a PhD thesis on every single one of these things and it would be super interesting, but to actually get a robot to do it is millions of dollars. So what ends up happening is people end up making these kind of smart connected equipment, and that's pieces of equipment that automate the physical actions via automating the mental actions. It tells you when something's done. It goes ping when it's ready to eat, right? But the problem with these is, as they become more complex, the actual human usability goes down. If you've ever worked in a kitchen and they've got a $5,000 oven, they're not programming the oven. They turn the oven on and they put the stuff inside. So what happens here is you thought you would be able to save a lot of money by not training people, but then the people that you didn't want to train don't particularly want to work for you because their job is monotonous and boring. So what we try to do at REMY is we basically try to allow machines to do the stuff that machines are good at, which is calculating things, and we try to allow humans to do what humans are good at, which is choosing recipes, cooking things, cutting variable shapes, and so on. And that's the way we operate. So generally what happens is, when you go to automate something, the reason pizza is a good thing to automate is you take the lessons from industrial manufacturing. You have a conveyor belt, you dump cheese on top, you dump tomatoes on top, whatever. So it's just basically kind of mimicking industrial manufacturing. This gets you so far, but your machine that makes pizza is now not going to be able to turn around and make burgers suddenly. It's a fundamentally different thing. Your machine that makes pizza cannot even make a calzone, because then now you suddenly got to flip the thing. So it's very limited when you're using industrial manufacturing. So the thing you have to think about is food is a product of technology. All food is a product of technology. And there is no reason to think that the food that you are going to be eating in the future, that we are going to be eating in the future, has any resemblance to the food that we are eating now. Ciabatta bread was invented in 1980. If you told me that you wanted to put a bunch of vegetables in cans, boil them for several hours, and then give them to me to eat, I would think you were crazy. But now I live in Spain, and I love fish in cans. But you still couldn't sell me on the idea if it didn't exist. White bread, frozen vegetables, all of this stuff, right? And we also don't believe that the food should be the same as it is right now. Because the food that is growing, the food that is profitable, the food that is increasing in revenue in the world right now is garbage. It's not good. It's not good for the planet. It's not good for us. So we want to radically disrupt the system by making it so that the food that is available is healthy, good for you, sustainable, and so on. And this is how we do it. And this slide's a bit light, so I'll skip it. Basically, optimizing McDonald's, optimizing Burger King. Actually, I shouldn't say anything bad about McDonald's. Optimizing burger chains is like adding an additional lane on a highway. It doesn't solve your existing problem. Your existing problem is the fact that you've built your entire infrastructure around cars. Build a train, build a walkable city, keep adding lanes on highways is silly. So what we did was we invented a new cooking framework. And the cooking framework that we operate in, here's another cool video of the other part of our company. The new cooking framework is operating around AI, right? And what we do is we take inputs from chefs, there they are, and we take the inputs from chefs and we combine them with the inputs from food scientists, and we combine them with the inputs from the environment that it's in. That is to say, my oven is this hot inside, is what I mean by an environmental variable. And the kind of knowledge that chefs have is subjective, intuitive, expressive, imaginative, fluid, abstract, and the kind of things that food scientists offer, and that, let's say, more objective analysis is systematic, quantifiable, analytical, structured, precise, all of these stuff, right? And it's not, one is not better than the other. You shouldn't give supremacy to a certain type of knowledge simply because it's easier to quantify. That's the thing that AI really enjoys doing. It's like, now we can quantify something, great, let's give primacy to this knowledge at the expense of other types of knowledge that are equally, if not more, valid, right? So we tried to combine all of this together in some kind of rhizomic, if you guys are familiar with that term, rhizomic as opposed to like a tree. There is no tree of knowledge. There's a rhizome of knowledge, right? It's the roots, not the branches. And it looks more like this than that nice one that we had. It's quite difficult to visualize. And rather than relying on huge amounts of data, which works really well if you're doing images and you have a user base of millions of people to click what a car is, it works much less well if you have to cook and label a bunch of data and you're wasting a huge amount of food and you have to cook all the food and things like that. So we try to not do that. So what we do instead is we label it with experts and food scientists, and these are what culinary engineers are, is we look at the food from both a data perspective and a subjective perspective and the cooking perspective. These are all of the equations that go into what tells our robot how to cook it. And it has all of these algorithms inside the cooking equation, and then that tells you, 1, what you're cooking, 2, what you have to do to the thing, and then 3, what you expect the result to be. And the result defines what the input is. So it's a self-reinforcing circle, I suppose. And the thing is that salmon is water content, fat content, density, weight, shape. But salmon is also flavor. Salmon is also texture. Texture is also mushiness. All of these kind of, if you read any food science papers, you always end up relying on a panel of trained people who are actually just graduate students at whatever university who define what was sour or what was not sour. Like, our panel found that this, and this, right? I'm not saying that's invalid, but if you're going to build it at the end on the consumer, on the person that's putting the thing in their mouth, you should have the person that's putting their thing in their mouth at the beginning as well. To transfer the knowledge across these two worlds is quite difficult. And so that's what we do. You can see here that we have, these are the different flavor profiles. These are all of the different physical attributes we have into. We also are able to, if the customer wants something to be medium rare versus well, that's another thing that goes into the algorithm. So all of this changes, but it's mostly based on this expert labeling I'm talking about. Now, the thing is, when it comes to cooking and processing food, we're actually really good at this already. Like, there exists a machine to cut tomatoes. We don't need to make a robot cut tomatoes if all you want to do is cut tomatoes. You don't need to make a robot cut potatoes if all you want to do is cut potatoes. We have a massive assembly line for that. The problem of optimizing the preparation of ingredients has been solved. The problem is the distribution of these ingredients in an equitable way, right? Like, we have more than enough food to feed everybody. The problem is it's not being given in the way because it's difficult to scale up a business that relies on healthy food, different food, variable ingredients. And so the result is you get this kind of homogeneous, boring food diet situation. So we know that these are tomatoes, and we know that these are potatoes, but your assembly line is not going to work if you put these potatoes in that assembly line. It's going to break, which is why you have to breed potatoes that are a certain shape and size, which is why you have to change the agriculture to fit your machine. And if you could just make it flexible at the beginning, using artificial intelligence, using a lot of different variables, you can then cook all of the different types of potatoes, all of the different types of tomatoes or tomatoes. And that's what we do. So what we do is we basically take kind of the world of food. Our system works. We have a couple restaurants in the US and some in Europe. And what happens is we work with chefs. Chefs say, this is our dish that we are cooking. They give us the information about the dish. We put it in like a magic black box, and I'm not going to tell you what it does. It gives you all of the inputs and the outputs of the food. We understand what needs to happen for it to be cooked the way they want it to cook. We take the inputs from the people that want it, and our robot cooks it. And it does it. Here's another video of the food we make. It's from an advert we had. And we do it. So it's not like some theoretical thing. We do it like all the time, constantly. We've had 4 different brands. We have 120 different dishes that we sell, done on these fundamental principles. And that's basically what my talk was. I told you it wouldn't take 15 minutes. There you go.